Hi, my name is Peter Wilder, and I am an HVACR drives application engineer at ABB. In this following self-paced lab, I'm going to walk you through how to set up an ACH580 drive for an HVACR pump application. In this lab, we're going to cover drive control wiring and programming. The goal of the self-paced lab presentation is to teach you how easy it is to wire and program an ACH580 drive for a pump application. Now this lab is made up of several smaller micro labs, you could call them. And I do recommend that you go through these labs in order as they will build on one another. By the time you complete all the labs, you'll be more familiar with how to program and wire up the ACH580 drive. This self-paced lab is made up of 5 sub-labs. And I recommend, as I stated before, that we go through these labs in order, but you could jump from one lab to the next if you want to see one key item. To start out with, the first lab, lab 1, we're going to enter in the motor data. We're going to set up the drive for a hardwire run stop. An analog's frequency reference will be connected to the drive. I'm going to set up the drive to ramp to stop if a stop command is given. In lab 2, we're going to program the drive with a low suction safety input switch, and we're also going to set up the drive to have a minimum frequency reference. Now, you must complete all the way to lab 2 in order to be able to run the motor. If you don't complete lab 2, if you just complete lab 1, you will not be able to run the motor, just as an FYI. Lab 3, we're going to set up the drive to be able to communicate over BACnet IP. And then in lab 4, we're going to set up the run stop and frequency reference to come from BACnet IP. And then the last lab, lab 5, we're going to adjust the name of the drive and fault contact information. Now to complete the following labs, you will need an actual drive. A demo drive will work perfectly fine, or a drive on a workbench will also work. On the right are 2 common ABB demo drives that we have produced over the years. The top one is a drive only, and the bottom one is a drive with a bypass. If you do have the drive with a bypass demo, you will want to set that demo case up for drive mode only. And if you have a drive on a workbench, for example, powered off a single-phase control power transformer, that will work perfectly fine. You can wire up maybe little toggle switches you have to the digital inputs in the drive to simulate, your hardwire run stop command. You can also use that to simulate our low suction safety in this lab. And also, if you have a little potentiometer knob, you could wire that up to simulate, like a 0 to 10 speed signal, for example, into the drive. One last item that is needed to complete this lab is a BACnet IP card. The part number for this card is an FB-IP-21 card. For labs 3 and 4, we will need this option card installed on the drive. Before we jump into the first lab, I want to provide you some important reference information. What I'm showing you here are the default settings for the drive's analog inputs and outputs, and the drive's digital inputs and digital outputs. In the following labs, I may ask you to make adjustments to the drive, when in reality, all that may be necessary is to land some wires on the drive, as the programming in the drive may be defaulted for that functionality. So it's not to be a trick, but use this information here I'm showing you as we go through the following labs, as you may realize it's very easy to set up the ACH580 drive for a pump application. As we go through the following labs, I will commonly use primary settings or the quick setup to program the drive instead of just going into the main parameter menu. Here I have links to some other YouTube videos that you can reference, the ACH580 drive's primary settings and quick setup. Let's start with lab 1 now. In the configuration request of this lab, the customer is asking that we set up the drive to receive a 0 to 10 volt speed signal that will represent 0 to 60 Hz linear. We're also going to set up the drive to receive a hardwire run stop command, and we're going to have the drive ramp to stop instead of coast. And we're also going to enter in the motor information into the drive. The motor nameplate data is 0.33 horsepower, 0.8 amps, 1650 RPM, 230 volts, and 60 Hertz. Now, if your demo case has different motor information, enter that information into your drive instead of what I have shown here in this lab example. Now, on the right, you can see I have an image of the drive with no wiring attached to any of the digital inputs or outputs or analog inputs. So before I show you where we're going to land control wiring on the drive, I want you to think about it a little bit, maybe reference the previous 2 slides before where I showed you the default information, and think about where you want to land the control wiring. You can pause the video right now if you'd like to take some time to think about it. All right, here you can see we're landing for the 0 to 10 volt speed signal, we're landing it on terminals AI1 and A ground. And for the run stop command, we're landing the wires on terminal 10 and terminal 13, which is DI1. So as you can see also, DI1 is set up for start stop already. And analog input 1 is set up for a frequency reference input. So it makes it pretty easy, we'll find out here, to set up the drive for these 2 applications, as no programming is necessary for the speed signal or for setting up the drive's hardwire run stop command. Now let's program the first part of Lab 1, which is the speed reference input, the hardwire run stop, and setting up the drive to ramp to stop. Now this is the first power-up screen that you'll see. You'll see the output frequency reference, motor current, and analog input 1 value. To get to programming, you'll hit Menu. And as I mentioned earlier, we're going to do most of our programming through primary settings. Now if you wish, at the end of this list, I hit the up arrow key to get to it faster. There is parameters. You could go into parameters here and program all the same functionality in the drive, going through all the parameters in the drive. This is a more complicated method that I'm not going to cover in these self-paced labs. Now, what is important to note is that at the end of each sub-lab, I am going to cover the modified parameters, and I want to show you where you see that information. If you go into parameters and you go down to this modified here, this is a list of all the modified parameters that are made in the drive or added to this list after we make adjustments to certain settings in primary settings. Okay, so this is where to see this information if you want to make sure your drive is programmed correctly. Now if we go back, we can go up to primary settings here. We hit select, and now we see under primary settings we have a couple different options. We have HVAC quick setup. I mentioned this in the beginning of the presentation, that this is a method for programming the drive. There are other ways of programming a lot of the same functionality that we're going to cover here, like our analog input and hardwire run stop. Start stop reference is another option where you can program these same settings in the drive that we're going to cover. So I'm going to use HVAC quick setup though, because I think it's a little bit easier. So first you can hit select, or you could hit the arrow over key. And we're going to first see under HVAC quick setup, under primary start stop, the setup by default is DI1, and that is where we landed our hardwire run command already. So no adjustments to the drive are necessary for the drive to receive a hardwire run stop command on digital input 1. Next, we're going to cover the analog speed reference. Here you can see primary reference from AI1. That's where we already landed our analog input wires, so that's good. Now we have to adjust the scaling. Is it 0 to 10 volts or is it 4 to 20? You can select the arrow button, and you can see here the range is 0 to 10 volts. If, for example, you did have 4 to 20 milliamp, you could make adjustments here for that, but we don't need to. And here you can also see this reference, 0 volts equals 0 hertz, 10 volts equals 60 hertz, and that was what the customer was requesting, so no adjustments are also necessary. So a lot of default settings already is how the drive comes out of the box. And the last item is we need to set up the drive for ramp to stop. Now at the very end of this list, under stop mode, you can see the drive is set up for coast to stop by default. Here we need to change it to ramp to stop. So we hit edit, and we hit the down arrow key, and now we can hit save. And now the drive is set up for ramp to stop. So we had to make one parameter adjustment in the drive, and we did that through the primary settings HVAC quick setup to do that. Now this completes the first part of Lab 1. Now for the second part of Lab 1, we need to enter in the motor data into the drive. So again, we'll go to primary settings, and here we're going to go to motor, and we're going to hit select there, and we're going to enter into this assistant here called nominal values, and we're going to answer some questions here and enter in this motor data. So to start out with, this drive is on a pump. It's a single pump. We're We're not doing multiple pumps, so we'll select single motor. And now we're going to enter in the motor data. What's a little trick here is don't hit next, hit the arrow button here. And we want to enter in 0.33 because I have a really tiny motor. If your motor has different motor data, enter in that data here. So I'm going to do, actually amps is, sorry, not 0.33, it's amps, 0.8 amps. The RPM is 1650. Voltage is 230. Frequency is 60 hertz. And down at the bottom here is horsepower. And this will be 0.33. And the type of motor is a basic induction motor. And now we hit next. The minimum and maximum frequency are adjustments that can be made in this assistant. 0 and 60 hertz are what we have right now as the requirements, so we'll leave these alone. And now it says, are you about to exit the assistant? Do you want to save the changes? We do. We'll select yes. And now we have entered in the motor data into the drive. Now as we complete lab 1, it's a good time to review and check and make sure your drive is programmed correctly. The best way to do this is to look at the modified parameter list in your drive. As I showed you earlier, that's under main menu, parameters, and modified. The list here on the left, starting with parameter 2103 stop mode, that should be the first parameter in your list, followed by group 99 parameters where your motor data is entered. Your motor data should match mine unless you have a different motor. On the right side here, I took screenshots of different sections of primary settings where we made these changes. So now review this information and make sure your drive is programmed correctly. And then you can move on to lab 2. Now moving on to lab 2, the customers asked us to connect a low suction safety circuit to the drive as a safety circuit. So if low water pressure is coming into the pump, the drive will automatically shut off the pump, protecting the pump from failure. The customers also asked us to program a minimum frequency reference of 30 Hz into the drive. This minimum 30 Hz will apply for both auto mode and hand mode. Now, on the right side here, you can see the current control wiring setup from the previous lab 1 on the drive. We have your analog 0 to 10 volt signal up on terminals AI1 and A ground, and we have a run stop command connected between plus 24 volts terminal 10 and digital input 1 on terminal 13. Where do you think we should hook up the safety circuit, which is normally closed, onto the drive? I'll give you a few seconds if you want to pause the video here. Here's a good time to do so, and I'll reveal the answer where I have selected to hook up the low suction safety circuit to the drive. Here you can see I've connected the low suction safety circuit to digital input 4, which is terminal 16. And the default setting of DI4 is start interlock 1, which is a normally closed safety circuit. Now by default, digital input 4 is set up already for a normally closed safety. So we don't have to make any programming adjustments to set up digital input 4 for normally closed safety, but we do need to make programming adjustments so that if the safety were to open, indication of a low input suction would appear on the screen. So to do that, we're first going to go to menu, primary settings again, and we're going to go to quick setup. And here you can see use of start interlock 1, check, and DI4 high, meaning in order for the drive to run, digital input 4 has to be closed. Okay, so that's already there by default. Now description text, the default description text is very generic start interlock, not very meaningful if you have, for example, any random safety attached to the drive. So we want to make this state what specific type of safety do we have attached. We have a low suction safety, so we'll hit edit. And here we can go through the list, and you can see all different types of safety. Some are for fan applications and cooling towers. And if we go down, we see low suction. So now I can hit save. Okay. And now we have set up the drive so that if DI4 were to open, you'll see low suction displayed on the screen, which is a lot more meaningful than just start interlock is open. Now the next part of lab 2 was to program in a minimum frequency reference of 30 Hz that will be applied for both hand and auto mode. So to do this, again, we're going to go to HVAC quick setup, and if we keep going down, we'll see this option called minimum frequency. You may have noticed this minimum frequency option also when we were entering in the motor data. At that point, we didn't know we had a minimum frequency of 30 hertz, so that's why we didn't adjust it then. That was in lab 1. But now in lab 2, we're going to edit this minimum frequency value to 30 hertz. And the important thing is this minimum 30 hertz is applied to the drive in both auto and in hand mode. Basically, any way the drive runs, any type of run source, the drive will always run at a minimum of 30 hertz. Let's finish up lab 2 by reviewing the modified parameters that would be added to the modified parameter list in the drive. Parameter 20.47 and parameter 30.13 are the only two parameters that are added. On the right here are some screenshots of the process that we used in primary settings and HVAC quick setup to make these modifications for reference. Lab 3, we're being asked to now set up the drive to be able to communicate over a BACnet IP network for monitoring purposes only. This means that the drive will still be receiving run, stop, and frequency reference via hardwire, and information such as, let's say, the output frequency of the drive, what's the output current, is the drive in a fault state or not. That information can be read from the building automation system over this IP network. So that's called just monitoring. Now, when we deal with IP communication, we're going to have to be given from the controls contractor an IP address and a subnet address. And then also, specific to BACnet, we're also going to have to be given a device object ID. So here you can see on the left the IP address of 192.168.1.8, the subnet of 255.255.255.0, and the device object ID of 4010. Now in the ACH580 drive, BACnet IP is not a standard option, so it requires a separate option card. Now if you open up the option card manual for the BACnet IP card, which is an FBIP-21 is the name of the option card, it'll show you where to install the option card, which is right underneath the keypad in slot 1, which is shown here on the right in the red box. And this is what the BACnet IP card looks like when it's installed. Note that you will need to use a T10 Torx screw in the lower left corner to tighten down a screw connection, and push in the red tab on top to help secure the card to the drive. Now let's program the IP address, subnet, and device object ID into the drive. To do that, we'll go to Menu again, as usual, Primary Settings, and HVAC Quick Setup. Now at the very bottom of this list, and I'm going to use the up arrow key as a cheat to get to the end of the list quicker, you can see Communication. So we'll select this, and you can see options of embedded field bus or field bus adapter. That's what we're doing, is field bus adapter. That's what the FBIP-21 card is. So we'll go down, and we'll hit Select, and we'll select Enable. Okay? Now, we'll then go down to Communication Setup. Now, if you're installing the card for the first time, there is going to be a period of time back there where some bars will be going across the screen for about a minute. I've already initially set up my card on the drive, so we didn't have to go through that process, but it is a good solid minute worth of time where some bars will be going across the screen during the setup process. Now, once you're in here, you can see the FBIP-21 option card, and the protocol's BACnet IP. And if you go down the order on the list, actually we have it third in the list, but device object ID. This needs to be 4010, so we'll edit this to 4010. Pretty easy. Max APDU retries, you can just leave it default 3. Now this is very important. We're being asked to program in a static IP address. The default for IP communication is to use a DHCP where there's not a specific IP address assigned to the drive, but 99% of the time when you're commissioning a drive, you're going to be given a specific IP address, which is a static IP address, which is specifically assigned only to this drive that you're commissioning. So we'll want to unselect this. This is always by default enabled. And now when we go down to IP address, we'll be able to edit the IP address. So here we're going to want to enter in the 192.168.1.8. So if I even go backwards here for the octets, we'll do enter in the value here. Okay, we now have the IP address entered, and now we have to enter in the subnet. Now it'll say custom by default here in the HVAC quick setup. We'll hit edit here. Now, if you look at the FBIP-21 manual, in the manual there you'll see a list of the subnets here. There's only, instead of entering this complete random set digits, there's a preset list of available options. And you can see here option 24 is 255.255.255.0. So we'll select this here. And we have now entered the information into the drive for this IP option card. You may also, I forgot, be given a gateway. If that is the case, enter in the gateway information here. Most of the time, you're not going to be given gateway information, but so you can just leave it as default all zeros. And then at the very end, we need to initialize the setup, this card to the drive, because it's a communication card. You kind of have two options. One is you could power cycle the drive now, or the other option is go down the bottom of the list and it says apply settings to field bus adapter. So you can just select this, and the drive's going to go into a little bit of a reboot here and initialize all the settings that we just made for the IP address, subnet, and device object ID for the VFD. And now that it has completed, the drive is now set up to be monitored over a BACnet IP network. To conclude Lab 3, here are the new modified parameters that you would see in the modified parameter list in the drive on the left. And here are some screenshots for reference of programming in the information into the drive for the IP address, subnet, and device object ID number. In Lab 4, we're now being asked to set up the drive so the run stop command and frequency reference now come over BACnet IP. Previously in Lab 3, we had just set up the drive for monitoring purposes only. So on the right is our current setup with hardwire controls for run stop command and a 0 to 10 volt signal in the drive. So what changes would be made now to the drive if we're to have the run stop command and BACnet and frequency reference come over BACnet IP? If you said obviously let's remove the wires, that's the answer. Yep, so now we can remove the wiring from AI1 and A ground, and also from plus 24 to DI1. That wiring is not needed, and as the command will come over the BACnet IP network. Now to program the drive so the run stop and frequency reference come over BACnet IP, we're going to go to main menu, primary settings, and HVAC quick setup again. And at the top of the list, we have the option to adjust where the primary start stop reference comes from. By default, as before, it was set up for DI1, digital input 1. We're going to change this, and we're going to set it to a field bus. Make sure you set the field bus, not embedded field bus. This is a field bus option card for BACnet IP. And now we have to adjust the frequency reference. Where's that going to come from? A primary frequency reference. Before it was AI1. I'm going to set this again to field bus. We have now programmed the drive so the frequency reference and run stop command come over BACnet IP. To conclude Lab 4, here are the two new parameters that are added to the modified parameter list, parameters 20.01 and parameter 28.11. And here are some screenshots as usual to show where I made the adjustments under HVAC quick setup to set up the drive for run stop and frequency reference over field bus or BACnet IP. Lab 5 is the last lab in the series of labs for commissioning an ACH580 drive on a pump. Now, Lab 5 is going to take advantage of a unique feature in the ACH580 drive if you're not familiar with this brand and model of drive. And this is the feature of customized text. The first piece of customized text we're going to adjust on the drive is the drive name. By default, the drive powers up with a name called ACH580. But this drive is on hot water pump 1. So we're going to want to change the name of the drive to hot water pump 1. So we'll do that in the following slide. And then the next piece of information we're going to adjust is the fault contact information. Now this is great in case someone's working, like for example, a graveyard shift, and if the drive goes into a fault and they're not sure what to do, we may want to make it easy on them and say, hey, contact so-and-so at their phone number. So these are two pieces of information we're now going to adjust in the drive. Let's now adjust the drive name and fault contact information in the VFD. To do this, as always, go to primary settings. Now, to adjust the drive name, we can do this under HVAC quick setup. It's at the end of the list. If you hit the up arrow key once, you can get to it faster. Drive name. We cannot adjust the fault contact information under HVAC quick setup. That's done underneath a different sub-menu option here. And at the very bottom of the list here, we have clock region display. If we select there, we also have drive name, and we also have the fault contact information. First, I'm going to show you how to adjust the drive name. So hit edit here. Now, the left arrow key is like a delete button. And if you hit the up arrow key once here and you get these double arrows, you can see we have different options of lowercase, uppercase, numbers, and all the symbols. So we want to adjust this to hot water pump 1, and uppercase kind of looks better for this. So I'll hit the left arrow key to get the uppercase letters. Now, knowing your alphabet is important here to make this go faster, as you can go through the list faster. H is closer to the beginning, so hit the down arrow key, got the H. Now to set the H, I'll hit the right arrow key once, now H is set. And now W is near the end, so I'll go up, and so on. Now I need a dash, so that's under symbols on the far right here. Now, from experience, I know that the dashes are faster to get to by hitting the down arrow key. So I'll go hit the down arrow key, get to a dash, then I'll hit the arrow over key once to set that. And now I need numbers, and this is hot water pump 1. So now I go down to 1, and now I have hot water pump 1. So I'll hit save, and you can see at the top of the screen here, hot water pump 1 is now the new drive name. Now let's set up the fault contact information. First, by default, fault contact information is disabled, so let's select, and we're going to enable it. Now, by going down one level here, we can edit the fault contact information. Now, this is quite a bit of text. I don't want to have you watch me enter all this information in, but you can see here I've entered in contact Bob at the phone number of all 8s. So same process as adjusting the drive name to adjust any type of fault contact information you want to enter. And then again, just hit save. And now if the drive were to go into a fault, this is the information that will appear at the bottom of the screen. Now to conclude Lab 5, let's review the modified parameters. Well, there are actually no new modified parameters. What is actually a little bit unique is the customized text for the drive name and the fault contact information are not actually saved as a parameter in the modified parameter list, so you will not see them. But on the right here, you can see some screenshots I've taken of where we made the adjustments for the drive name and fault contact information. This now concludes the self-paced lab for setting up the ACH580 drive for a pump application. If you have any questions, please reach out to your local ABB representative.